Trigonometry. How do we know when we are looking at the question that that's what we are dealing with? Well, once you see any drawing that has to do with triangle, you know it's going to be trigonometry, you know it's going to be page 16 in your maths table. Okay, let's see. A fish shop has a vertical sign outside its front door. In the diagram below, the sign is represented by FH. So that's the sign with FH equal 3 meters. So the length of H, 3 meters. A cable is tied at the top of the sign F, and we can see that here. And it is secure at the point G on the horizontal ground. When they are saying horizontal, that means that creates right angle here. G is 1.4 meters from the base of the sign H. And again, we can see that from G to H, 1.4 meters, as shown in the diagram below, not to scale. So what do we need to do? Use the Theorem of Pythagoras to find the length of the cable, GF. So this is the length we are looking for. Give your answer in meters, correct, to 1 decimal place. When we have a right angle triangle, we have always two options. Either it's Pythagoras or trigonometric ratio. Here, they are very kind. They are telling us that it's Pythagoras that it will work here. So first of all, we go to our maths tables, and here, page 16, this is where we have Pythagoras. So we write down our formula. In order to use the formula, we need to know what is C, A, and B in our own triangle. And in your maths tables here, you can see it telling you what are those letters, what do they represent. So C is the side that is opposite the right angle. So that's what we do. This is the right angle, the side that is opposite, that is C. Now that leaves us with A and B. Which is A, which is B? For Pythagoras, it doesn't really matter which will be A and which will be B. Why? Because we are adding them here. Okay, let's replace letters with numbers from our question. So our C, that is GF, that GF is taken to the power of 2 equal A. We decided 1.4 will be A. So that's taken to the power of 2 plus B. B is 3, and that's as well taken to the power of 2. Oh, let's move a little bit that second part. Now, what we are looking for is what? GF, not GF taken to the power of 2. How do we eliminate that power of 2? Always the same way. When we want to eliminate power, we take a root of the other side. In this case, a square root because power is 2. And we put that in the calculator, we press equal, and to 1 decimal place, we will get 3.3 meters. Okay, let's have a look at next question. Shows that the size of angle FGH. So just let's take our triangle here now to the next part. So where is our angle FGH? So that's where our angle, always that middle letter tells you where the angle is. So we have to show that this is 65. So basically this is the same way as if we don't know, we have to calculate. We just know what's the answer is going to be. So when it comes to the angles, again, this is the same right angle triangle. Our page 16 saying that when you have a right angle triangle, you have two options, either one of the trigonometric ratio or Pythagoras. Now, to make that simple, that choice, what I'm always saying here with right angle triangle, Pythagoras and trigonometric ratio is that Pythagoras, that's formula C to the power of 2, B to the power of 2, A to the power of 2, all those letters represent side, the length of the side of the triangle. When it comes to trigonometric ratio, here each one of them have an angle involved and two sides. Now, since we are looking for an angle, well, Pythagoras is not going to help us because it doesn't have an angle in a calculation, but trigonometric ratio, yes. However, we have three trigonometric ratio. So which one are we going to choose? And the same like with Pythagoras, first thing we put those letters to our own triangle. So starting with our angle we are looking for, so in this case, this is the angle I'm looking for, or sometimes this is the angle given to us. The side that is opposite that angle, that's my small a. When it comes to the right angle, that doesn't change, the side opposite that C, and from the previous calculation, we know that's 3.3, so that means the remaining side is B. Now let's just take our ratios here so that we can see how it works. So I am looking for what? Capital A. So each one of them have capital A. I have value of C, so I have this number. I have A, I have this number. And then I have B, so I have this number. So as you can see in this case, we can use any of the three ratios, it will work. Now, let's quickly just run over each one of them. So we are saying if we are using sine, my angle is A, and that equals my value of A here is 3, my value of C 3.3. So I want an angle, not sine of an angle. How do I eliminate sine? I take it to the other side and it becomes inverse, meaning to the power of -1. And then we put that in our calculator, press equal, and we get our answer that yes, indeed is 65. What about if we choose cos? So again, cos A, and now value of B on top of the fraction, that is 1.4, value of C 3.3, and again to eliminate cos the same way we do with sine. Oh, I'm saying sine and therefore I'm writing sine. The same way we take it to the other side, become inverse, meaning to the power of -1. And again, we put that in the calculator and we get 65. What about if we choose tan? So therefore, again, tan of A is 3, B is 1.4. And again, to eliminate tan, take it to the other side, like with the other two, it become inverse, meaning to the power of -1. And again, we put that in the calculator, we press equal, and we get is 65. Okay, let's have a look at next part. So the second part, a second cable from G is tied to the sine at the point K, where K is a halfway up sine FH. So halfway up, what that means that it divided my FH into equal parts. So if the whole length was 3 meters, so now each part is 1.5 meters long, isn't it? Since it's divided into 2. Myriad says that the size of the new angle KGH, so KGH, so this angle, is half the size of the angle FGH, the one we just calculated 65. So that's the way it was before, that's the way it's now. So now the question is she correct? And we have to use calculation to support our answer. So in order to find out if this angle is half of it, well, we need to calculate the size of this angle, isn't it? And the same idea, we're going to use one of the trigonometric ratio. So again, let's put letters to our triangle. So this is the angle I'm looking for. Therefore, the side opposite is small a. The side opposite the right angle is C, and therefore the remaining side is B. Now here, I want capital A, I want small b, and I want small a. So again, let's just take our trigonometric ratio from our table. Oops, that's not what I wanted to move. My apologies. Now, there it is. Okay, so now I'm saying, okay, which of those three ratios have exactly these three elements? I can see that tan is the one, so it is tan we're going to use here. Therefore, tan, again, of my angle A will equal small a on top of the fraction 1.5, small b at the bottom of the fraction 1.4. And again, if I want to find an angle, I take tan to the other side. It becomes inverse, meaning to the power of -1. And then we put that value in our calculator. We press equal, And the number we are getting is what? 47. And not 47 is not half of 65, isn't it? So we are saying, no, she is not correct. And that's our calculation to prove that.